In example 1, we used a function and substituted in a specific x value to find an output or a y value that we needed. In example 2, we took a function that they provided and were able to create a function table. By randomly choosing some x values, substituting them into the function, we were able to come up with the f of x or the y values. And we were also able to identify the domain and range in that situation. Now we're moving on to being able to write a function, and we're starting out with a word problem. So notice in 3 examples so far, we've looked at functions as they relate to actual functions or equations, to tables, and now to word problems. So in this situation, we have 770 peanuts in a jar of peanut butter, okay? We want to know the total number of peanuts as a function of the numbers of jars of peanut butter. So how can we write an equation or a function that explains or describes this scenario? Well, one of the easiest things to identify first is what I would assume you would know by now, or what you would call a constant rate of change. So notice it says 770 peanuts in a jar, or we could easily write per jar. So that identifies 770 as our constant rate of change, okay? Now, if you were trying to figure this out, if I simply asked you how many peanuts are in 10 jars, what would you do? Exactly, you would take the number 10 and multiply by 770. And if there were 20 jars, you would do 770 times 20. And if it was 100 jars, you would do 770 times 100. So it seems to be that you're going to take 770 and multiply that by the number of jars of peanut butter, which just so happens to be represented by the letter J. So I'm going to take 770, multiply that by J, and what is that going to get us? Well, that is going to get us the total number of peanuts. And right here, that happens to be represented by, in the function notation, P of J. So here we have our function. P of J is 770 times J. So we want to make a few notations here. First of all, if we are familiar with a function or an equation, we should know that J, which is in the spot where the X would traditionally have, is the independent variable, okay? So let's label J as the independent variable, which means that the number of total peanuts would be the dependent variable. Now, does this make sense? If we say the simple phrase, the total number of peanuts depends on the number of jars of peanut butter, that does make sense. In other words, I cannot tell you the total number of peanuts until you tell me how many jars we're working with. So that takes care of which one is dependent, which one is independent. And simply by looking at the equation, you have a coefficient is usually in front of the independent variable, so it's pretty clear to see that that would be J. Let's talk a little bit about what we can do with this function. Well, they said in the problem that they want to know how many total peanuts are in 7 jars. So now we simply substitute J, instead of J, 7. And 770 times 7 gets us 5,390. So we know that there are 5,390 total peanuts in 7 jars of peanut butter. And you could do that for any value. You would substitute it in. Now, what does this tell us about our domain and range? Well, our domain, or the x value, or the independent variable, it doesn't make sense to have anything negative in this situation. Can you buy negative jars of peanut butter? No, so that doesn't make sense. Does it make sense to have any fractions? In other words, do you buy half jars of peanut butter? No. So the domain, any numbers that you put into this function would be whole numbers. So the domain, or our x values, are going to be any whole numbers. And any whole number that you're going to put in is going to ultimately be multiplied by 770. So our range then would be any number multiplied by 770, or we could write that as multiples of 707. So, real quick, we take our word problem, we identify the constant rate of change, the independent and dependent variable, we write a function like we did right here, we substitute and use that function to get an answer, all the while recognizing what is our domain and what is our range. Hopefully this helps. Go ahead and try the got it problem about a rubber stamp.